Audio Jungle. Audio Jungle.
Hello everyone, myself Singh Maurya, and hope you all are doing well. So guys, today we'll solve GATE 2017 problems, and this is problem number 39. It was asked for 2 marks. So the problem is a pilot was flying a single engine propeller aircraft and maintaining a steady level flight. Okay, steady level flight at a lift coefficient given zero point 0.5 at an altitude of 500 meter. Due to some emergency at the same altitude 500 meter, the pilot had to fully deploy the landing gear. If the pilot wants to maintain steady level flight still at the same CL equal to zero point 0.5 and at the same altitude, which of the following control action should the pilot undertake? Option A, move the elevator up and decrease the throttles. Option B, move the elevator up and increase the throttle. Option C, move the elevator down and decrease the throttle. Option D, move the elevator down and increase the throttle. Okay. So see, this problem is what conceptual based problem. So here what happening? Suppose this is what sea level, okay, and here aircraft is what flying. All right. So now for this aircraft, you say this is what landing gear, okay. So generally, whenever it is uh, takeoff condition, completely or fully takeoff condition, then uh, landing gear will not be deployed, obviously. Okay, but here it is clearly mentioned due to some emergency at some altitude. And what is the altitude? It is 500 meter, right? So half kilometer. So obviously, in this case, that deployment of landing gear should not be there, but it is said mentioned clearly. It is due to some emergency. So you just think like whenever this landing gear will be deployed, so what will happen? Because see, this aircraft is not moving in forward direction, so obviously air will come and hit to the component of the aircraft. So once it is deployed, whenever it is flying, okay, so that time extra drag will be added. No doubt about it, extra drag will be added. Hmm? I mean, whatever the normal condition, from the normal condition, once it is deployed, okay, landing gear, once it is deployed, so extra drag will be added. That one thing you need to keep in your mind. Okay, number one. So whenever drag will be added, so if you want to maintain a steady level flight and at the same CL, if you want to maintain aircraft at a steady level condition, then what should you have? So simply you should have more throttle. More throttle means you are going to give more thrust. Throttling is related to the propulsive system. So if you are going to increase the throttle, means you are going to increase the thrust. So it is very clear now, because extra drag here has been added because of the deployment of landing gear. Okay, so extra thrust required to maintain that drag, because steady level condition, what is the steady level condition? Thrust is equal to drag. Okay, so because of this deployment of the landing gear at 500 meter due to some emergency, so drag will be added because you have deployed landing gear. So extra drag will be added, hence drag will increase now. So obviously you need to increase the thrust. So only at steady level, so only it will be, so only that aircraft will able to fly at a steady level condition. Okay, if you want to maintain steady level flight, then once drag added because of the deployment of the landing gear, so you have to increase the thrust. So decrement of the thrust or decrease the thrust, totally wrong, so you can remove this part. What option you have? You have B and D. All right. So hope you all understand why decrement of thrust is not a correct statement. Okay, done. Now it is clear, like thrust you have to increase, so throttle will increase. That is the one point, it is clear. Now another thing is what, elevator up or elevator down. Okay, you just think, because if you check that landing gear is here, okay, and so once it is deployed, so because drag increases at the same time, uh, this aircraft will try to nose down, because once drag will be increasing, one thing, and whatever the air is coming, that air will hit to the landing gear, because it is flying at 500 meter. Okay, so that air will come and hit to the landing gear. Okay, so what will happen, that aircraft will have nose down condition. See, once air will come and hit to the landing here, so that aircraft will try to go nose down condition or pitch down condition. Nose down, nose down or pitch down, pitch down. Okay, so but you need to maintain a flight at steady level. Okay, level flight should be there. There should not be any descent flight. Descent means it is suppose going to lose the altitude. No, you want to maintain at steady level condition, level flight. So if pitch down will come, so it may follow the descent condition that you don't want. You want steady level, so you have to uh, move the elevator up. Okay, if elevator will move up, suppose this is the elevator, and if you move up, this is the elevator up and elevator down. Okay, elevator up, and here we have elevator down. So this is what, this is the aircraft here. Okay, and this is the elevator. This is the aircraft here, and suppose on main wing, uh, that tail wing, elevator will be there, right? On horizontal stabilizer, elevator will be there. So this part is what here, and this is the like horizontal component. On horizontal component, elevator will be there. Okay, so once elevator will go up, so that will come and air will hit to the elevator, because it is up condition. Okay, and this is the down condition. So if it is up condition and air will hit here, then automatically it will go nose up condition. Okay, but if suppose elevator is what, down. Okay, elevator is what, down, suppose like this, so air will come and hit, so this elevator, because of this, that moment, you may have nose down. So if elevator is what, down, then nose of the aircraft will go down. If elevator is up, then it that nose will go up. Hope you understood, right? So because of the landing gear here, I told you it is going nose down condition. To maintain steady level, you should have a nose up. So when you will get nose up, when elevator is what, up. So your option B is correct answer. I hope you got the correct analysis for this, because this is, I told you, this is the analysis base, or you can say this is the conceptual based question. You have to apply the basic concept only. Okay, nose up, nose down concept you have to apply. Okay, and you have to very basic, that is drag, like one any extra component comes in contact with the free stream, so automatically drag will be increasing that time, like here landing gear. Okay, that's the reason deployment of landing gear is what not there at any altitude once it is completely takeoff condition. um, because it will produce unnecessary drag, parasite drag. So always uh, landing gear will be retracted when it is completely take off, and when it is going for the landing case again, it will be deployed. Okay. So anyway, hope you understood this problem and that analysis also. Any doubt? If you have still, then you can write comments. So I will again explain this. Okay. All right. We'll go this next problem. This is again asked in GATE 2017. Okay, and question number 40 for 2 marks. So read this problem. A conventional low speed aircraft, right? A conventional low speed aircraft had the following aerodynamics characteristics. They have given CD naught. What is the CD naught? What is the CD naught? It is the parasite drag, right? Or zero lift drag. CD naught is the parasite drag, or it is also called zero lip drag. Okay. Now they have given E. What is the E? E is the Ostwald. Okay. Ostwald efficiency. The aircraft was flown to maintain a steady level flight and minimum thrust required. Okay. It is the minimum thrust. It is given condition. Okay. Minimum thrust required. It is given condition. Very special. Okay, at a lift coefficient of CL. So this minimum thrust, and at that minimum thrust required condition, CL is given how much? 0.8. The numerical value of aspect ratio of the wing is, okay, the numerical value of the aspect ratio of the wing is. So here they are asking what is the aspect ratio. We need to calculate. All right. So this question, it is like a aspect ratio here they are asking. Okay, but one condition they have given, that aircraft was flown to maintain steady level flight and for minimum thrust required. Okay, so that is the one clue. It was here it is given, so you can write, at at steady level flight condition, at a steady level flight, what is the condition? Thrust is equal to drag and lift is equal to weight. For any aircraft, okay, for any aircraft, this is the basic condition. Okay, what is the basically weight? That will be equal to lift. Okay, that is the main steady level condition here, and whatever the thrust which is required to move in forward direction equal to drag will be the opposing force, so it will be acting at CG. That you know very well. Okay, so here you can say thrust required. Okay, and see this condition, it is the minimum thrust required. I will mention this. minimum thrust required means TR is what? Minimum. If thrust required is minimum and steady level, so drag will also be minimum. So D minimum is the condition, very well known condition called minimum drag condition. Minimum drag condition. Yes or no? What is the mean of this? How you can understand this by the graph? So that graph, you know, it is very well known graph. If you draw graph between drag and velocity, so this is very well known graph. If you okay, so basically this is nothing but induced drag, and this is nothing but parasite drag. Huh? Parasite drag, and parasite drag, as I mentioned, it is denoted by CD naught, and induced drag it is denoted by CDI. Yes or no? So at one place, both, huh? Like parasite drag and induced drag, it is crossing to each other at one point. What is the point? This is the point. So here, whatever the velocity you may get and whatever the drag here you may get, okay, this drag will be the minimum drag. Okay, this is the minimum value, right? This is the minimum value of the drag. See this plot here, it is saying resultant of parasite and induced drag. This is the resultant value. So this is the drag. Okay, so here obviously this part is the minimum drag point. All right, anyway, and this velocity respect to minimum drag will be minimum drag velocity, VMD. So at point A, or at point O, you just say this is the point O. So at point O, what you are getting? You are getting CD naught parasite drag is equal to CDI. Yes or no? Wherever that two lines are cutting to each other, so at that point value must be same. That is the basic mathematics. So as I mentioned, this is the drag y-axis and x-axis is velocity, and here we are showing the two types of drag, parasite drag and induced drag. So you know very well this graph will be the induced drag and this plot will be the parasite drag. So both are cutting at one point, so obviously that cutting point will have a equal value, first thing. Second thing, as I told you, this y-axis is the drag, so wherever it is cutting, and that value will give the minimum drag value, and with respect to that minimum drag value, whatever the velocity at that point, that will be the minimum drag velocity. So at point O you got minimum drag condition. What is the condition at minimum drag? It is nothing but CD naught is equal to CDI. This is the minimum drag condition. This is the minimum drag condition. Always remember. Okay. All right. You know very well that drag polar. What is drag polar? CD is equal to CD naught plus CDI. Parasite drag plus induced drag coefficient. That if you give the one equation and if you draw it, okay, so that will be called as a drag polar, and here it is nothing but CD naught plus induced drag is nothing but KCL square. All right. So from here you can understand CD is equal to CD naught for the minimum, CD is equal to CDI for the minimum thrust required or minimum drag condition, and this CDI is nothing but KCL square. This is for what? This is for minimum drag. This is the one very special case when minimum drag condition will be there, then this will be the value minimum drag. Or if drag is what minimum, then it is the minimum thrust required condition. All right, hope you understood. So because in the problem it was given like minimum thrust required, right? See, it is given minimum thrust required. So I told you minimum thrust required is nothing but minimum drag condition. Minimum thrust required is nothing but minimum drag condition, and for the minimum drag, see, there is the mathematical derivation also, a minimum drag condition, but we are not going to derive any equation. As I mentioned, this is the solution class, right? I mean solution I am giving. So for the solution, basic formula I have to use, and that formula will be used directly, because this whatever the session I'm covering from 2007 to 2020-22, that is the solution session. Okay, so whenever it is like unnecessary derivation is not required, then it is totally time wasting here. So better we'll use direct this relation. And already I told you I will cover the subjects also, so that time I will give full derivation. All right. Anyway, so always remember, this is very important. Okay, very important. You need to remember this point is important. Okay, thrust required is nothing but obviously it is a drag. And what is the minimum drag condition? This is the minimum drag condition. So this is also very important. You need to make a mark. CD naught is equal to CDI. This is the minimum drag. Anyway, so you got this CD naught is equal to CDI. What they are asking in this problem, check. They are saying numerical value of the aspect ratio. So aspect ratio we have to calculate here. Anyway, you got CD naught is equal to KCL square. What is the K? K is nothing but 1 upon pi E AR. You know that, into CL square, and is equal to CD naught. Check CD naught value. It was given here. If you check, read the problem. CD naught is 0.020, E is 1, and CL is 0.8. So we'll write all the value. 0 point here. It is 0.020 is equal to 1 upon pi into E is a 1. Aspect ratio you have to calculate. This is the aspect ratio into CL. CL value is also given. Yes or no? What is the value of CL? It is given. Read, check. CL is 0.8. So keep this value 0.8. Now you just calculate this data and tell me how much you are getting. 0.8. No? Okay. So aspect ratio will be 0.8 square um, divided by pi. Okay. Divided by 0.020. It is 10.18. 10.18 aspect ratio. This is the fill in the blank problems. There is no unit for the aspect ratio. Okay, so 10.18. So we'll write here. It is 10.18. Up to 3 decimal it is mentioned. So 10.185 I'm getting. 10.185 I'm getting. Done. No unit. I hope you understood this problem. Okay, any doubt comes in your mind, you write comment, I will reply. Okay, done. Now this is the another gate problem, same 2017. It is question number 43. Again, it is asked for 2 marks. So this is also for 2 marks. Okay. Now read this problem. An aircraft is to be designed to ensure that it has enough excess power to achieve steady climb. Okay, steady climb, and at flight path angle, that angle is given gamma is equal to 10 degrees. So this is the climbing angle. Yes, this is the climbing angle. Maintaining CL by CD 10. All right. The numerical value of thrust to weight ratio of the complete aircraft to meet the above requirements under standard atmospheric condition will be, okay. So you just write this data. What is the given value? You just write given climbing angle. Okay, climbing angle gamma, it is given how much? 10 degree. 10 degree. CL by CD is also given how much? 10.0. All right. And that's all. They are asking calculate thrust to weight ratio. Thrust to weight ratio, here it is asked. See, this problem is asked for 2 marks. Okay, that's when this is the climbing of the aircraft, a problem. Okay, that separate topic it was given, right, and it was covered also in my subject session. But now see, we'll go for the analysis for the climbing flight. So if you go for the climbing flight, see, this is the climbing of the aircraft. Okay, now see, so that climbing angle here you can show, this is nothing but gamma. All right, and obviously if you go for the component, force component here, so this will be weight W perpendicular to the velocity, will have a lift. This is the gamma climbing angle, so this will also be gamma, so this component will be W cos gamma, and here this component will be W sin gamma. Okay, thrust will be in forward direction because it is a propelling force, and drag here, this will be the drag component opposite to the motion of the aircraft. So what equation you got? Check. You got D plus drag plus W sin gamma is equal to thrust. Yes or no? Number one. Number two, that lift component. So W cos gamma is equal to lift. These two equations we have to use for our analysis. Thrust to weight ratio they are asking, right? Okay, no problem. We can calculate thrust to weight ratio. All right. Remember CL by CD here it is given. Okay. Now, so I can write the same equation once. Thrust is equal to drag plus W sin gamma, and lift is equal to W cos gamma. Am I right? L equal to W cos gamma. Okay. So thrust to weight ratio. So better you just uh, you calculate the value of weight and divide in equation. Okay. So check this equation. Thrust is equal to, you just divide by weight both side. All right. Now from this equation you can calculate what is the W. W is nothing but L divided by cos gamma. Yes or no? So wherever, because thrust to weight ratio we need to calculate, so no need to change the value of weight here. You just keep it like the same because we need to calculate this drag, and here we can change W. W is equal to L cos gamma plus it is 1, so sin gamma. So thrust to weight we need to calculate, okay, D by L cos gamma plus sin gamma. All right. So you can write this thrust to weight is equal to, what is the value, cos gamma. So here you can write cos gamma L by D, because here it was given D by L. So D by L you can write 1 upon L by D, meaning is same. As per your convenience, you can change the that I mean numerator and denominator accordingly you can manage. Okay, plus sin gamma. All right. You know L by D. What is L? Half rho V square S into CL. What is drag? Half rho V square S into CD. So if you check, all the value will be cancelled out, CL by CD. Yes or no? So L by D is nothing but CL by CD. C by W cos gamma CL by CD. Hope you understood why I have written here in terms of L by D. No? Because CL by CD value they have given. Check how much it is. Is 10. So you, and what is gamma? 10 degree. So you just place the value. Everything you now you have. You just place all the data here. So you make it. Cos 10 divided by CL by CD is 10 plus sin 10. You can calculate thrust to weight ratio. What is the value? Let me check. Cos 10 divided by 10 plus is 0.272. Okay, is point up to 3 decimal. So 0.272 up to 3 decimal. Okay, here 0.272. This is the answer. I hope you all understand. Any doubt? As I said, I will definitely reply if you write anything in comments related to the problems. So this is the answer, up to 3 decimal. All right. So these problems they had asked in GATE 2017, like in GATE 17, that performance problem, 3 problems I think they had asked. So it is solved now. And if you have any, like, still any doubt, if you have, then you write comment in comment box, so I will reply. Okay, anyway, so this solution session will be continuous. Very soon I will upload GATE 2016 solution also, so you guys keep watching the video. Okay, and keep practicing the previous year problems, as well as that problem you can go through the aircraft design and performance by Anderson. That book also you have to follow, because that is the main book for your aircraft performance. So like the video, subscribe the channel, so that whenever I will upload new videos, so you can get the notification. All right, thank you all, thank you so much, thank you.